Okay, let's review writing an equation, writing equations of lines given different situations. So the first one, we're going to start with 2 points, -4, 2, and 2, 5. And we're going to write this in slope-intercept form. If you don't remember, slope-intercept form is y equals mx plus b, where m is the slope and b is the y-intercept. Okay. We do not have either one of those in this situation. We have 2 points, but we can easily find the slope. The slope is change in y over change in x's. Change in y's over change in x's. Okay? Easy way to remember that, which is the Greek delta. Delta y over delta x. Change in y's over change in x's. So it's just a little subtraction. We can find the slope here. So just off to the side, slope is, or m is, change in y is 5 minus 2. Okay, I'm going to write it out for you. And 2 minus -4. Just happen to pick that nicely so that everything turns out positive. You can't always do that, though. Well, obviously, because you can end up with negative slopes. 5 minus 2 is 3. And 2 minus -4, same as 2 plus 4, which is 6. 3/6 is the same as 1/2. So the slope we're dealing with is 1/2. Okay, so we want to use this as our slope. That's going to be m. Now, there's a couple methods of going about this. You can take this 1/2 and plug it right in here at the m, and then take one of your points and plug in the y value and the x value, solve for b, and then back substitute. I think that one takes a little bit more time and a little harder than remembering point slope form. Okay, because currently I'm the owner of a point, either one I want to choose from, or this one. Okay, 1 point, and I own the slope. I know both of those things about this situation, so point slope form will help me a lot, because those are the 2 things that are needed to write the form, write the equation given point slope form. So point slope form is what I want to use. Oops. Okay, point slope y minus y1 equals the slope parentheses x minus x1. Okay? So it's pretty easy. So I'm going to take y minus the value for y in the ordered pair I pick. Well, I guess I really don't care which ordered pair I pick. I'm just going to use this one. It's got 2 for the y. So I'm going to do y minus 2 equals the slope 1/2 parentheses x minus, well, the x value up here is -4, so x minus -4. And now all I have to do is solve it for y. Okay, that's going to take a little bit of distribution here. And remember that minus a negative is plus. I forgot parentheses. Okay, so we end up with y minus 2 equals, my line here is getting in the way. Y minus 2 equals 1/2 x plus 1/2 of 4, or 1/2 times 4 is 2. Okay, and I'm close because I should have y equals mx plus b. Right now I have y minus some number equals mx plus some other number, not necessarily b, but I'm close. So get y by itself by adding 2 to both sides, because that's the opposite of subtracting 2. Okay, so I have y equals 1/2 x plus 4. So that's a nice way of finding the slope-intercept form of a line passing through 2 points. Okay, now let's look at it. This is just a variation on that problem. It gives us the x-intercept and the y-intercept instead of giving us 2 points or giving us a point in the slope. Okay, it basically gives us 2 points because the x-intercept is where the line crosses the x-axis, which means that the y value has to be 0, because there's no rise on that point. If it's crossing the x-axis, it's right on 0. Okay, so this point, the x-intercept point, is actually 4, 0. And the y-intercept point, then the converse of that, or the opposite of that, if it's landed on the y-axis, that means that the x value has to be 0. Okay, so it actually did just give us 2 points. So this problem ends up being almost identical to the last problem, just the numbers are changed. And it gave us some nice zeros to work with. Okay, so let's find the slope. Change in y's. 8 minus 0 is 8. I'm going to kind of skip through this a little bit quicker. And then 0 minus 4 is negative 4. Well, 8 divided by negative 4 is negative 2. So our slope is negative 2 this time. Now we have a point and the slope. Okay, well, there is an easier one than the other to use. But it probably doesn't make too much of a difference. If we want to solve for y, it'd be really nice if after we plugged in to point slope form, that we just had y by itself. So that would mean if we plugged a 0 in for y1, it'd be really nice. So, well, this one has a 0 for y1, so let's do that. Y minus y1 equals the slope, negative 2, parentheses x minus x1, which is 4. Pretty nice and simple, because y minus 0 is just y. And then distribute the negative 2, and you get negative 2x plus 8. And we have our equation in slope-intercept form for the line that passes through or has an x-intercept of 4 and a y-intercept of 8.